As we discussed in the Protect Systems and Data module, VirtualBoot uses Oracle VirtualBox to create a temporary virtual machine using a ShadowProtect backup image as the virtual hard disk. Other environments, such as Hyper-V and VMware, are not compatible with VirtualBoot. Following VirtualBox installation, using VirtualBoot is easy and can take only minutes to get a machine up and running, regardless of the amount of data involved. For information regarding the installation of Oracle VirtualBox, see the VirtualBoot lesson in the Protect Systems and Data module. VirtualBoot creates a new branch of your backup chain by creating a writable incremental file and a corresponding XSP file. VirtualBoot lets you quickly recover a failed system in a temporary VM, allowing users full access to production data while you rebuild the failed system. Mount a backup image as a VM to verify the restored system functions properly, or use VirtualBoot to test updates or new software on a replica of your production system without affecting the live production data. If you have already installed VirtualBox as shown in the Protect Systems and Data module, you can create and configure a VM. To launch the VirtualBoot wizard, right-click the ShadowProtect backup image file that you want to use and select VirtualBoot. Note, you may also start VirtualBoot by navigating to the VirtualBoot executable in the ShadowProtect program file directory or from a Windows command prompt. Select Next. If the backup image is encrypted, you will be prompted for the password. In the Backup Image List window, specify the backup image files that will be used by the VM and select Next. Add Image File lets you add a backup image file to the VM. Use this if you have a separate data volume you want to add to the boot volume. If the selected backup image file is encrypted, you must provide a valid password to access it. Note that VirtualBoot will list all volumes that were part of the backup job. Remove Image File lets you remove a backup image file from the VM. Specify Boot Image lets you designate the boot volume in the VM. Typically, VirtualBoot detects this automatically, but if you include multiple bootable volumes in the VM, you can select the volume that VirtualBoot designates as the boot volume. In the Options dialog box, specify how the VM is created and then select Next. Automatically create the new virtual machine. If you do not select this option, you must manually configure the VM in VirtualBox. In either case, VirtualBoot creates the XSP files that VirtualBox uses to define the virtual disk drives in the VM. Note that VirtualBoot always places the boot volume in the numbered disk XSP file. Automatically start the new virtual machine. Deselecting this option will allow you to fine-tune VirtualBox settings before starting the VM. Specify the name of the new virtual machine. By default, VirtualBoot creates a name based on the host machine name. Specify the amount of memory, or RAM, to allocate to the new virtual machine. Specify the VM network adapter type. Supported options include NAT Pro 1000 MT Desktop, which adds a generic network adapter to the VM that uses network address translation, or No Network Adapter, which excludes a network adapter from the VM. Use this option for testing where no NIC is needed. Select Advanced for additional VirtualBoot options. Import only one volume per hard disk drive within the virtual machine. Deactivate Windows within the virtual machine. Store write buffers in a different directory than the image files, on a faster device perhaps. And override personality used to configure the virtual machine OS volume, used for support only. Confirm the options you have chosen and select Finish. VirtualBoot generates the files necessary to support the new VM and, if specified, creates the VM and launches it for use. In the Plan for Disaster Recovery module, you should have answered the question, how long will my solution need to run? The answer to this question may fall into three categories: VirtualBoot as a test, VirtualBoot as a temporary failover with failback to the original hardware, or VirtualBoot as a temporary failover with failback to new hardware. This is very important in relation to VirtualBoot because it is intended as a short-term data access solution. VirtualBoot uses a chain of multiple backup image files as the virtual disk. Once a VirtualBoot VM runs, it will continue to add to the backup image chain that existed in the original Windows environment. This disk access and management is significantly slower than a regular virtual disk. Over time, VirtualBoot performance will degrade beyond acceptable limits. This degradation will result in a system crash and the loss of your data. If you are unable to fail back within a week, you will need to employ an alternate solution to protect your production data. Regardless of the reason for using VirtualBoot, when you no longer require the VM, you will need to power it off. How you do this depends on your reason for using VirtualBoot. The next slides will cover failback for the three main categories mentioned previously. Use VirtualBoot to conduct a non-production test of your DR solution. This method is a verification of the correct path to a production server on the recovery side after a failover. Only a few users will require access in order to verify the connectivity. No changes will be made to live production data in VirtualBoot. Keep in mind, you're testing pieces and processes, but not the actual recovery, with no requirement for failback. To power off a VM without saving changes, select Machine and close VM. Select Power off the machine and Restore current snapshot VirtualBoot. Select this option only if you want to revert back to the VM's original state. Select OK. In some instances, VirtualBoot can be used as a temporary failover with the intent to fail back to the original hardware. To continue your original image chain in the VM, launch ShadowProtect, and under the Backup Jobs tab, select your backup job and then unpause to resume the backup job. Remember, this is a temporary solution, and the longer it is used, the greater the risk of a VM crash and a loss of data. To power off a VM and save changes to your production data, select Machine and close VM. Select Power off the machine, but do not select Restore current snapshot VirtualBoot, or you will lose all incremental backup data written in the VM since its creation. Select OK. If a server were to fail, you can use VirtualBoot to quickly restore a machine into a temporary virtual environment and continue to add incremental backup images to the virtual machine until the server is replaced. Or, if all the servers were to fail, you could VirtualBoot each server and continue to add incremental backup images to each of their existing backup image sets until they are replaced. To continue each original image chain in the VM, launch ShadowProtect, and under the Backup Jobs tab, select your backup job and then unpause to resume the backup job. Remember, this is a temporary solution, and the longer it is used, the greater the risk of a VM crash and loss of data. Once the servers are replaced, you can use ShadowProtect Recovery Environment and Hardware Independent Restore to fail back to the new hardware. More information regarding Recovery Environment and Hardware Independent Restore can be found later in this module.